In this video, we will look at two examples of adding or subtracting vectors by adding or subtracting their horizontal and perpendicular components. And we will do so using the new unit vector notation system that you have just learned. The assumption is that you are familiar with the idea that vectors can be represented as the sum of two perpendicular components, and that you are familiar with unit vector notation. Let's start with an addition example. For now, our focus is just on doing the math. We'll worry about how we apply this to physics situations in a later lesson. The two vectors we're going to add are a vector that is 170 units long at 120 degrees. That blue arrow represents that vector. And we're going to add to it a vector of 50 units in length, pointing in the direction of minus 70 degrees. So there's our diagram showing the green 50 unit vector added to the blue one. As with any vector addition diagram, the resultant, the sum of the two, is the vector that points from where we started to where we ended up. That red vector represents the sum of the blue and the green one. Sketching out a diagram like that at the beginning is a useful thing to do, because now we know to expect an answer that points to the left and up. It's a good way of checking the results of our calculation. So how do we actually calculate the magnitude and direction of that vector? We start by writing each vector in its component form. So 170 units at 120 degrees, you're going to pick up your calculator and type in 170 times the cosine of 120. That gives you the length of the horizontal component, which is to the nearest unit minus 85 units. So we could write that as minus 85i in our notation system. And the vertical component, 170 times the sine of 120, will be 147. So using our notation system, a vector of 170 units at 120 degrees can be written as minus 85i plus 147j. We're going to do the same for our second vector, and when we do that, we will get 17i minus 47j. And we are adding those two vectors. Now, all of this is basically addition. We've got a negative 85i, we're adding 147j, we're adding a 17i, and we are adding a negative 47j. So it's all addition. We don't really need the brackets. We can eliminate the brackets there. Negative 85i plus 147j plus 17i plus negative 47j or minus 47j. Now this is kind of like basic algebra. Those unit vectors are a little bit like variables. The i's are horizontal unit vectors, the j's are vertical unit vectors. We can add similar things. We can add horizontal unit vectors to other horizontal unit vectors. We could do the same with verticals, but we can't add horizontals to verticals. Let's regroup here so that all of our horizontal unit vectors are together and all our vertical unit vectors are together. So we've got minus 85i plus another 17 i's plus 147j's, and we are subtracting another 47j's. We can do the math there. We can add i's to i's. Negative 85 i's plus another 17 i's is a total of negative 68 i's. We can do the same thing with our j's. 147 j's minus another 47 j's is a total of 100 j's. And there we have our answer. There is the sum of those two vectors expressed in component form. The sum of those two vectors is a vector that's pointing 68 units to the left and 100 units up. And if we look back at our original diagram, we can see that red vector appears to be something very similar to that, so we're probably right. If the point of the question was just to figure out the sum, then that's a perfectly valid answer. Expressing a vector in component form is a standard way of expressing a vector. However, let's just finish it off by converting that back into magnitude direction form for completeness sake. As you should already know, the magnitude of a vector, we're going to use the Pythagorean theorem. It's going to be the square root of negative 68 squared plus 100 squared, and that gives us 121 units. And to get the direction, we are going to take the inverse tangent of the y component over the x component. So the inverse tangent of 100 over negative 68. And when you do that, your calculator gives you an answer of minus 56 degrees. But if you recall from an earlier lesson, that may not be the correct answer. When you use the inverse tangent function, you're asking your calculator to tell you which angle has a tangent, in this case of 100 over negative 68. And there are two angles which have any given tangent. One of them is negative 56. The other one is the one that points in the exact opposite direction. So you have to check your answer. Negative 56 degrees, that direction is to the right and down. Our vector, we can see from the components from the diagram, is pointing to the left and up. So in this case, we want the direction which is opposite negative 56 degrees, which is easily found simply by adding 180 degrees, and we get 124 degrees as our direction. There are our two vectors added together using components. We break the vectors up into their components, we add and subtract the like components. That gives us our answer in component form. If we just want an answer, that's fine. Sometimes we might also want to convert it back into magnitude direction form. Let's look at an example of subtracting vectors. Why would you want to subtract your vectors? Well, you've actually been doing that all through your physics career so far, but we'll look at that later. For now, we're just treating it as a pure math exercise to learn the system. So I have a vector of 65 units at minus 50 degrees, and I'm subtracting a vector of 100 units at 160 degrees. Well, now that we know our unit vector notation, and we can break vectors into components, any vector addition or subtraction is basically done the same way. Let's start by writing each vector in its component form. So again, you're going to pick up your calculator and you're going to type in 65 times the cosine of negative 50 degrees. And that will give you 42 as the horizontal component. And you're going to type in 65 times the sine of minus 50 degrees, which will give you negative 50 as the vertical component. So this is 42i plus negative 50j, which we usually just write as minus 50j. Doing the same for the second vector, 100 units at 160 degrees, we get minus 94i plus 34j. So there's our two vectors in component form, but this time we're not adding them, we're subtracting them. Since it's all addition and subtraction, we can remove the brackets, but you need to be careful here. We get 42i minus 50j. Now this is where most people make their mistake. We're not subtracting negative 94i, we're subtracting the entire vector. We're subtracting negative 94i, which is the same as adding 94i, and we're subtracting 34j. Now the rest we can proceed just as we did with the last example. Let's group the like components. Let's group the i's together, 42i plus 94i, and let's group the j's together, minus 50j minus 34j. And now we can add like components. 42i plus 94j is 136 i's, and minus 50j's minus another 34j's is a total of minus 84 j's. And there is the answer to our subtraction. When we subtract 100 units at 160 degrees from 65 units at minus 50 degrees, we get a vector which is pointing 136 units to the right and 84 units down. Once again, if we just wanted an answer, that's a perfectly valid way of expressing the answer. But again, for completeness sake, let's just convert that back into magnitude direction notation. Using the Pythagorean theorem, we will find the length of that vector is 160 units. And the direction, we're going to find the inverse tangent of negative 84 over 136. And the calculator gives you minus 32 degrees. But we need to double check, is that the right direction or do we want the other one? Well, the components are telling us that we're going to the right and down. Negative 32 degrees is to the right and down. So there is our answer. Now that you know how to break vectors into their components and you know the unit vector component notation, all vector additions and subtractions are basically done the same way. Break the vectors up into their components and add or subtract like components, as the case may be. Doesn't matter how many vectors you're adding. What if we were adding 3 vectors or 5 vectors? Well, it just means I have 3 I components to add and 3 j components to add. All vector addition and subtraction can be done the same way, and with practice it proves to be very quick and simple.